let us start solving the problems of conduction. जो भी टॉपिक्स पढ़ लिए हैं, whether it is unsteady state conduction, heat generation, without heat generation, whatever be the cases. So I have selected few questions, few good quality questions based on these concepts. One by one सारे क्वेश्चन सॉल्व करेंगे. वीडियो पॉज कर लेना, सॉल्व करके देखना एंड होपफुली आप सारे क्वेश्चन सॉल्व कर जाओगे. कंडक्शन इतना मुश्किल नहीं है. पहला क्वेश्चन देखते हैं. द क्वेश्चन सेज कंसिडर अ 2 meter high and a 0.7 meter wide. So this is a 2 meter high and this is 2 meter, 0.7 meter, 0.7 meter wide, है ना? 0.7 meter wide bronze plate whose thickness is 0.1 meter. Actually this width is not in this direction. ये width जो होगी ये इस direction में है, तो ठीक है. तो that becomes 0.7 meter. Okay, having a thickness of 0.1 meter. Okay, 0.1 meter. One side of the plate is maintained at a constant temperature of 600 Kelvin. So you can take any side. Suppose this temperature, this side is maintained at a constant temperature of 600 Kelvin, while the other side is maintained at 400 Kelvin. Okay, 400 Kelvin. ठीक है. कुछ चीजें हम लोग ये क्वेश्चन सॉल्व करते वक्त भी सीखेंगे. आई टोल्ड यू देयर आर सम स्मॉल कॉन्सेप्ट्स. तो क्वेश्चन सॉल्व करते वक्त आपको मैं बताऊंगा. यू कैन नोट डाउन एज अ कॉन्सेप्ट ऑल्सो. ओके, एज शोन. ओके, then the question says that the thermal conductivity of the bronze plate can be assumed. अच्छा, आप यहाँ पे ये बोलोगे कि सर मैं इसको 0.7 क्यों ना मानूं, ये क्यों ना मानूं, तो उस सब की टेंशन नहीं लेनी है. If language will be suppose if language is slightly confusing, then don't worry, in the exam diagram will be provided to you. ठीक है, हमने सब्जेक्ट पढ़ा है, मैं आपको कॉमन सेंस यूज करने को बोल रहा हूँ. कॉमन सेंस यूज करके अगर आपको ये डायग्राम समझ आ रहा है तो बनाओ, अगर कॉमन सेंस नहीं यूज कर पा रहे हो तो डायरेक्ट बना लो. इन गेट एग्जाम, suppose if this kind of scenario is there that the language is quite confusing, even this can be the probable diagram, even the 0.7 meter, and this can be the probable diagram. In that case the details, the figure will be provided to you. ठीक है, तो अपने को वो सोच के टाइम खराब नहीं करना है. ओके, द थर्मल कंडक्टिविटी ऑफ द ब्रोंज प्लेट कैन बी अज्यूम टू वेरी लीनियरली. वो बताया मैंने कि सॉलिड्स की थर्मल कंडक्टिविटी लीनियरली वेरी हम लोग अज्यूम करते हैं. एज अ के नॉट is equal to 1 plus beta t, the same temperature, where k naught is 38. K naught is, what do you think, what is the unit of k naught? You see here that it is given k naught is equal to 38 watt per meter per Kelvin. तो ये तो थर्मल कंडक्टिविटी वाली यूनिट ही होगी, है ना, watt per meter per Kelvin. एंड बीटा इज, कभी आपसे छोटे छोटे क्वेश्चन पूछे जा सकते हैं, व्हाट इज द यूनिट ऑफ बीटा, वहां पे सॉल्व कर सकते हो. बीटा इज 9.21 into 10⁻⁻⁴ per Kelvin. That is the data given. Disregarding the edge effects and assuming steady state one dimensional heat transfer, determine the rate of heat conduction through the plate. So steady state है, one dimensional है, determine the rate of heat conduction through the plate. So ये conduction हो कैसे रहा है, rate of heat conduction. And please note that we have to find capital Q. Be very careful that in question आपको capital Q पता करना है या small q पता करना है. Now कुछ चीजें आपको याद रखनी है. मैंने आपको पूरा डेरिवेशन कराया, यहाँ डेरिवेशन करने मत बैठ जाना. डेरिवेशन इसलिए मैंने कहा, देखो डेरिवेशन फॉर्मूला रट लोगे तो भी क्वेश्चन सॉल्व हो जाएगा. डेरिवेशन करके रखने से इवन यू आर रेडी फॉर दोस क्वेश्चन विच आर स्लाइटली ट्रिकी, जो थोड़ा डेरिवेशन के अंदर से चीजें निकाल के पूछते हैं. तो डेरिवेशन तैयार रखनी है. इफ यू रिमेंबर द डेरिवेशन, when k was changing linearly with temperature, I told you that the formula for calculating q was same as a normal slab where k was constant. The only thing is the k that I will use here will be the k which is calculated at the arithmetic mean of these temperatures, right, multiplied by area. So what will be the area? This is the direction, the perpendicular area I should take. So 2 into 0.7 ka, right, and what else, delta t, right. So L by Ka was the resistance. Okay, so that means the delta T, which is 600 minus 400 divided by L. And what is L? 0.1 meter. Of course, आप बोल सकते हो कि सर 0.7 मीटर क्यों नहीं, but आप मान लो उसमें और कुछ नहीं कर सकता अभी. This is not a problem from gate, so do not worry about this. Okay. Now, what is the meaning of Km? If you remember that Km was the arithmetic mean of k calculated at these two temperature, or you can say that k calculated at arithmetic mean of these two. What is the arithmetic mean of 600 and 400? 600 plus 400 is 1000. 1000 by 2 is 500. So at 500, if you calculate the value of k naught into 1 plus beta t1 plus t2 by 2, so that becomes 500. है ना। तो 500 पे कैलकुलेट करेंगे द वैल्यू ऑफ k, दैट बिकम्स k नॉट विच इज 38। ऑल्सो चेक द यूनिट्स, क्या यूनिट में कहीं पे मीटर की जगह सेंटीमीटर है, मिलीमीटर है, वॉट की जगह किलोवाट है, नथिंग लाइक दिस इज देयर, नो यूनिट्स कन्वर्जन इज रिक्वायर्ड। सो 38 मल्टीप्लाइड बाय 1 प्लस बीटा, व्हाट इज बीटा, 9.21 into 10 power minus 4 and multiplied by 500, that becomes beta। सॉल्व कर लेते हैं इसको, ठीक है। यूज वर्चुअल कैलकुलेटर्स, इस तरह के क्वेश्चंस के लिए आप वर्चुअल कैलकुलेटर यूज किया करो, मैं नहीं कर रहा बट आप लोग हमेशा यूज करो इसके लिए। सो 9.21 मल्टीप्लाइड बाय 500 एंड ओके दिस प्लस 1, सो दैट बिकम्स 1.4605 multiplied by 38, that becomes 55.499. So this is only the mean value of k, 55.499. You can take 55.5 also. If this is the value of k, then q means the heat rate is equal to 55.499 multiplied by 2 into 0.7, that becomes 1.4, right? 600 minus 400, that becomes 200, okay, divided by 0.1 meter. अब यहाँ जो आपके पास Q आएगा दैट विल बी इन वॉट, जो Q की वैल्यू आएगी वो वॉट में आएगी, है ना। आप किलो वॉट में एक्सप्रेस करना चाहें कर ले, मल्टीप्लाइड बाय 1.4 into 200, राइट, एंड दैट डिवाइडेड बाय 0.1, सो दैट बिकम्स Q इज इक्वल टू 155,397.2 वॉट, ठीक है। छोटे छोटे क्या इस तरह के क्वेश्चन आ सकते हैं, ये इतना भी आसान नहीं है। देखो आपने चीजें पढ़ ली हैं तो आपको चीजें आसान लगती हैं कि सर ये तो आता है, आता तभी है जब तुमने पढ़ा है। एंड द सेकंड थिंग, जो पढ़ा है भाई वही आएगा ना पेपर में। ऐसा नहीं है ना कि मैं आपको पढ़ाऊंगा कुछ और पेपर में कुछ और दूंगा, या फिर आपको एग्जाम में कुछ और देखने को मिलेगा, है ना, कि मैंने आपको पढ़ाया ईस्ट पेपर में वेस्ट आएगा तो सर वेस्ट से क्वेश्चन करते हैं, ऐसा नहीं। क्वेश्चंस तो इसी में से आएंगे, यहीं में इसी क्वेश्चंस में इन्हीं छोटी छोटी चीजों में हम गलती करेंगे, राइट। सो इनकी इतनी प्रैक्टिस कर ले, इवन गलतियों की इतनी प्रैक्टिस कर ले कि मुझे मेरी गलतियां रट जाएं, दैट व्हाट कैटेगरी और व्हाट टाइप ऑफ मिस्टेक्स आई एम डूइंग रेगुलरली, आई शुड हैव अ लिस्ट ऑफ दोज मिस्टेक्स एंड आई शुड रिमेंबर ड्यूरिंग द एग्जाम दैट ओके आई रेगुलरली डू मिस्टेक एट दिस पॉइंट, at this in these kind of problems, so I should be extra careful while solving these kind of problems, okay। So this was a simple numerical where k was thermal conductivity। ऐसे क्वेश्चंस को आप सॉल्व करो तो भाई डिराइव करने की जरूरत नहीं है। हाँ, आप डिराइव करके चेक करना चाहते हो कि आपको चीजें याद है कि नहीं है फॉर द फर्स्ट टाइम व्हेन यू आर सॉल्विंग दिस काइंड ऑफ प्रॉब्लम्स, सो यू कैन ऑलवेज डू दैट, ठीक है। सो दैट वाज द क्वेश्चन, राइट। आई ऑलवेज टेल यू दैट व्हेनेवर यू सॉल्व अ न्यूमेरिकल प्रॉब्लम, मेक अ हैबिट ऑफ यूजिंग 4 digits after the decimal during the calculation, fine। The final answer should be rounded off according to the statement of the problem। अगर आप डेसिमल के बाद 4 डिजिट यूज कर रहे हैं, इट इज वेरी लेस प्रोबेबल कि आपका आंसर जो है रेंज के बाहर चला जाएगा। कई बार स्टूडेंट्स शुरू में ही राउंडिंग ऑफ कर देते हैं, सपोज दे आर मल्टीप्लाइंग 2 क्वांटिटीज एंड दे आर गेटिंग 7.2356, so they will simply, or 7.2982, and they will simply write this at 7.2 or 7.3। तो ये राउंडिंग ऑफ अगर आप शुरू में ही कर दोगे और आपने 4-5 बार राउंडिंग ऑफ कर दिया तो जो फाइनल एक्सप्रेशन है हो सकता है लेस चांसेस कि रेंज से बाहर चला जाए। गेट के जो रेंजेस आपको दिए जाते हैं वो इस कैलकुलेशंस के साथ दिए जाते हैं कि किसी ने अगर 2 डिजिट यूज करी है, 3 डिजिट यूज करी है तो आपका फाइनल आंसर आ जाएगा। तो यू शुड हैव अ हैबिट। कई बार आप देखोगे किसी स्टूडेंट्स के साथ ऐसा होता है, और जब ये चीज होती है तो बहुत खराब लगता है कि सर ओनली बिकॉज माई आंसर वॉज नॉट इन रेंज, everything was perfect, only because my answer was slightly out of range I was not able to get marks in the concept was clear, the calculation was fine, right? So make a habit of using 4 digits after the decimal while doing your calculations, right? And the final answer, it should be rounded off according to the statement। कई बार statement होती है rounded off up to 2 decimal places, rounded off to nearest integer, rounded off to next higher integer। the next higher integer और nearest integer में अंतर है, ठीक है। और जब नियरेस्ट इंटीजर भी बोला जाता है तो आप ये मत सोचा करो कि सर अगर बाई चांस मेरा डेसिमल 5.86 आया और किसी का 5.36 आया, वो तो आंसर 5 लिखेगा, मैं तो आंसर 6 लिखूंगा। इन दैट केस रेंज भी ऐसी रहेगी 5 to 6, डू नॉट वरी अबाउट दैट। बट इसीलिए सेफ रहने के लिए, कम से कम हमारी मेहनत खराब ना हो उसके लिए, मेक अ हैबिट ऑफ यूजिंग 4 digits आफ्टर द डेसिमल फॉर कैलकुलेशंस एवरीवेयर, ठीक है। और कैलकुलेटर है यार हमारे पास, हमें कौन सा हाथ से कैलकुलेशन करना, तो कर लो जितनी ज्यादा एक्यूरेसी यूज कर सकते हो, फाइन। कोशिश मैं भी जब पेपर देता हूँ मेरी कोशिश नहीं रहती कि ज्यादा से ज्यादा एक्यूरेसी, मुझे एक्यूरेसी का बड़ा ध्यान रहता है, ठीक है, कि जो एक्यूरेसी यूज कर रहा हूँ, जो फिगर्स यूज कर रहा हूँ वो काफी एक्यूरेट रहे हैं, ठीक है। Second question says, consider a long resistance wire of radius 0.2 centimeter. ठीक है, this is the radius of wire. जब क्वेश्चन में रेडियस या डायमीटर दिया है, रीड द क्वेश्चन वेरी केयरफुली वेदर इट इज रेडियस और डायमीटर. समटाइम्स डायमीटर इज गिवन, वी हैव टू अप्लाई रेडियस इन द फॉर्मूला, वी यूज डायमीटर डायरेक्टली इन द फॉर्मूला. सो इस तरह की मिस्टेक्स होती हैं. ठीक है, सो R1 is equal to 0.2 centimeter and thermal conductivity of wire, so K of wire is equal to 0. It's not 0. It is 15 watt. 15 watt per meter per degree Celsius. 15 watt per meter per degree Celsius. The moment you see that there is meter and there is centimeter here, आपको यहीं पे careful रहना है that whenever you multiply things, you divide the things, please be careful about the units. There should be homogeneity in the units in which heat is generated uniformly as a result of resistance heating. मैंने आपको बताया था in current carrying conductors, heat is generated at a rate of, this is volumetric rate of heat generation. Different symbol has been used, but उससे कोई फर्क नहीं पड़ेगा. 50 watt per centimeter cube. Okay, the wire is embedded in a 0.5 centimeter thick. This is thickness, this is not the radius. So this is the wire, right? This is the wire in which heat generation is taking place. After this wire, this is the axis, suppose. The radius is 0.2 centimeter. After this wire, what is there? There is only insulation, there is cladding. ठीक है, अच्छा insulation में heat generation हो रही है क्या? Of course not. You know that in insulation there is no heat generation. It is only, heat is only getting transported, it is only getting conducted in the insulation, correct? So this is the insulation, correct? Only heat is getting conducted. The thickness is 0.5 centimeter, I guess. Yeah, so the wire is embedded in a 0.5 centimeter thick, so this entire radius, the total radius becomes 0.7 centimeter. Okay, ceramic layer, and having the K of ceramic is 1.2. The K of ceramic is 1.2 watt per meter per degree Celsius. Okay, if the outer surface of this ceramic layer means this surface temperature is Ts, which is given as 45 degrees Celsius. Please note कि Ts temperature मतलब surface का temperature और medium का temperature जरूरी नहीं है कि same हो. In this problem there is no role of medium, but please be careful कि ऐसा ना हो कि आप medium temperature और surface temperature को same ले लो in case some data is not given and it needs to be calculated. And you think that medium temperature and surface temperature are same, ऐसा नहीं होगा. Okay, Ts is 45 degrees Celsius. What we have to determine? Determine the temperature at the center of the resistance wire. Means I have to determine this temperature. Do you know that for symmetric condition, this temperature is equal to Tmax? So let us write Tmax. And also we have to determine the interface temperature, means Ti. ये temperature determine करने, and this temperature is Ts, which is 45 degrees. Very good question. एक बार पॉज करके सॉल्व करो ट्राई करने का. एंड मुझे पूरी उम्मीद है कि इस क्वेश्चन में आप फंसोगे. ठीक है, इस क्वेश्चन को सॉल्व करने का देखो, ट्राई टू सॉल्व बाय योरसेल्फ. ज्यादा टाइम मत लो, टेक 5 मिनट्स. 5 मिनट्स ज्यादा है, बट स्टिल टेक 5 मिनट्स, ट्राई टू सॉल्व. देखो सॉल्व कर पाते हो कि नहीं कर पाते हो. सी, in this problem the heat is being generated only in the wire, not in the insulation. So there are some limitations, but it is steady state problem. Okay, you know that at steady state I can relate the Tmax and Ti by one equation, which was Tmax minus Ti is equal to Qg, which is here written as G, multiplied by R square divided by 4K. That was the relation which relates these two temperatures. Is Tmax known to us? No. Is Ti known to us? No. If both Tmax and Ti are not known, I can't use this equation, right? Okay, let us talk about these two now. In the insulation, only heat transfer is taking place, no heat generation is taking place. So I can write that Q is equal to, in that form, that current is equal to potential difference by resistance, जो फॉर्म में मैंने आपको पहले भी लिखना सिखाया, Ti minus 45 degrees Celsius divided by resistance. It is a cylindrical body. What is the resistance for a cylindrical body? Log of R2 by R1. R2 will be 0.7. अभी वैल्यू डाल देते हैं 0.7 and R1 will be 0.2. Log of R2 by R1 divided by 2 pi KL. So let me write 2 pi KL in the numerator. 2 pi into K of wire. What is K of wire? Okay, K of wire is, okay, I'll write K of wire here. 1.2. Chalo, 1.2 is the K of wire and L. Okay, now length of the cylinder is not given to us. फिर से, even if you see the second equation, Ti is not known, even Q is not known, L of cylinder is not known. आई होप आपने दोनों इक्वेशन लिखी होगी. अगर ये दोनों इक्वेशन भी नहीं लिख पाए हो तो इसका मतलब भाई पीछे दोबारा रिवाइज करने की जरूरत है. गो एंड डू द रिविजन ऑफ ऑल द टॉपिक्स, ऑल द चैप्टर्स. ओके, but in these two equations still you find that something is missing. What is missing? First of all, length. Okay, forget about length, we'll talk about that. Okay, be careful about the units. What about this q? You know that at steady state we have discussed that heat generated in the system, in the entire system. What is the system? The system is this, jahan heat generation ho rahi ho, that is only the wire. The heat generated must be equal to heat leaving the system, and heat leaving the system is nothing but Q. The rate of heat transfer. What is heat generation? Don't say 50. 50 is the volumetric rate of heat generation. तो E generation क्या हो जाएगा? मैंने आपको कन्वर्ट करना सिखाया है. 50 watt per centimeter cube multiplied by pi, that is pi. And what is R? R 0.7 लेंगे कि 0.2 लेंगे? It is 0.2 because जिस बॉडी में जनरेशन हो रही है उसका जो रेडियस है वो केवल 0.2 है, वो 0.7 नहीं है. So 50 into pi into 0.2 square, right? 50 into pi r square into L. Units conversion are required or not? This is watt per centimeter cube and this is L centimeter into 0.2 centimeter square. I don't think that unit conversions are required. So this will be 50, right? From here I can calculate the value of Ti. But what about the conversions? Conversions. Okay. This L has to be in meter, right? This L has to be in meter. Why? This L has to be in meter because this 1.2 is in watt per meter per Kelvin. So this L is in meter. If this L is in meter, even this L has to be in meters. Correct? अगर ऐसा नहीं करूंगा, then there won't be unit. Because देखो इसी L को later on I'll cancel out with this L. Later on when I'll equate these two things, this 50 into pi r square into L, I'll cancel out this L and this L. करेक्ट. यहाँ यूनिट्स की कंफ्यूजन हो सकती है आपको. आप बोलोगे कि सर कोई फर्क नहीं पड़ता, ये सेंटीमीटर क्यूब, ये सेंटीमीटर क्यूब, इट विल बी कैंसिल्ड. ओके, but in that case it will be cancelled only if this L is in centimeters. If this L is in centimeter, I can't cancel out this L with this L because this 1.2 is in watt per meter per Kelvin, right? So that is meter per degree Celsius. So meter is there. So either you convert all the data in meters, कर लेते हैं, ठीक है? So in that case it becomes this value will become 50 watt per centimeter cube. So that becomes 50 into 10 raised to power 6. Centimeter cube becomes 10 to the power minus 2 raised to the power 3 minus 6, and then 10 to the power 6 into pi, that will be watt per meter cube. Centimeter is 0.2, so 0.02, okay? Yeah, that is square. Now this is in meters, right? This is the heat generated per unit time, and this must be equal to Q, and Q is equal to Ti minus 45 into 2 pi into 1.2. देखो अगर आप इस 1.2 को सेंटीमीटर के फॉर्म में बदल दो तो ये कुछ करने की जरूरत नहीं है. आई होप आप यूनिट्स को समझ रहे होगे. अगर यूनिट्स को नहीं समझ रहे देन प्लीज सॉल्व दिस प्रॉब्लम अगेन केयरफुली. देयर इज नो प्रॉब्लम हियर बिकॉज दे आर डिवीजन, दे आर गोइंग टू बी कैंसिल्ड एनी हाउ. ओके, सो लेट अस कैलकुलेट दिस वैल्यू. इट इज कमिंग आउट टू बी 50 into 10 to the power 6, right? And pi will be cancelled, right? Common, इसलिए देखो L नहीं दिया यहाँ पे, pi will be cancelled, L will be cancelled. So 50 into 10 to the power 6 and that multiplied by 0.002 square. Okay, that divided by 2.4. Step by step calculations कर रहे हैं to avoid any mistake. Correct? And that multiplied by log of 3.5. Okay, so log of 3.5, correct? 104.3. So 104.3 and Ti becomes equal to this plus 45. So it is coming out to 149.3. So that is the interface temperature. See the difference. Ti is coming out to be, Ti is equal to 149.39 degrees Celsius. That is the interface temperature. Of course, it should be less than the it should be higher than 45 degrees and less than the maximum temperature. Now the same can be substituted here, and in this case you'll be having the equation as T max minus this temperature. Now let me write here T max, we have to find T max also, right? Minus 149.39 लिख लो, 4 लिख लो, it's your choice, is equal to Qg r square by 4k. Now here I'll be taking the K of wire, not the K of insulation. That K is also given in meters, right? So either you convert this K into centimeter, or you convert this QG or R, आप वो जी जो भी conversions है वो कर लें, है ना? That is equal to, suppose I write here 50, इसको convert कर लेते हैं मीटर में, so that becomes 15 to 10 power 6 watt per meter cube. R is 0.2 centimeters, right? Yeah, R is 0.2 centimeter, radius of the wire, so that becomes 0.002 square. Okay, yeah, that becomes 0.002 square. Okay, 0.002 square divided by 4. Okay, now everything is meter, so not a problem. 4 into 15, let's see. We are getting 0.002 is equal to this and multiplied by 50. That divided by 60. 15 for the 60, right? Yeah, and that plus 149.39, 149.39, this is giving you T max is equal to 152.7 degrees Celsius. I hope the problem is clear. आपने solve करके देखा होगा, very conceptual problem, and the problem where many of you are going to make mistake. The reason being that please understand that when generation is taking place, I can never write that Q is equal to driving force by resistance. So you can see that I have only written Q is equal to driving force by resistance from this only for this cladding, only for the insulation, not for the other portion. Also, you should understand that if Q is not given, you know that at steady state Q leaving from here. Don't say Q leaving from here, because Q here and Q here is not same. ये भी एक फंडा है यहाँ पे. I told you that when generation is taking place, Q is a function of location. So Q here and Q here will be different. But Q here and thereafter Q everywhere will be same. ये fundamental है. अगर ये fundamental clear है तो आप generation plus conduction की problem में गलती नहीं करोगे. The problem can further be made complex by including convection, by including the medium here. So that was a very nice problem on conduction plus heat generation. I hope you were able to understand. Okay, let us take the next problem now. These two problems are not from GATE. I have also selected some problems from GATE, some nice problems, so that I can cover each and every detail. Whatever detail I have discussed in class, everything must be covered. Okay, so let us talk about the third problem. It says this was the resistance wire. Okay, a 3 millimeter diameter, 3 millimeter diameter and 5 meter. See, this is diameter. So D is equal to 3 mm and length is equal to 5 meter. And 5 meter long resistance wire is tightly wrapped with a 2 millimeter thick plastic. Thickness is given to you. Okay, so I have a, again there is a wire. Okay, there is a wire. Okay, what is the diameter of this wire? 3 mm means the radius will be 1.5 mm. So जब भी आपको diameter और radius की बात लगे, आप तुरंत पहले confirm करके लिख लिया करो that it is radius or it is diameter, otherwise you will make mistake. And 5 meter long is tightly wrapped with a 2 mm thick plastic cover. So 2 mm thick, so there is an insulation. Okay, there is an insulation here. Okay, so let us make the insulation. What is the thickness of the insulation? Don't say radius, the thickness is given to you. Okay, what is the thickness of the insulation? It is 2 mm, right? Electrical plastic was, okay, 2 mm means this entire will be 3.5 mm. Okay, 3.5 mm. It is given that thermal conductivity of the insulation is 0.15. K of insulation is 0.15 watt per meter per degree Celsius. ठीक है? Electrical measurements indicate. अब यहाँ पे थोड़ी सी करंट की थ्योरी है. You can expect कि ऐसा क्वेश्चन आ सकता है. अभी केमिकल में या फिर अगर आप मैकेनिकल में भी देखो तो ऐसे क्वेश्चन बहुत कम आए हुए हैं. केमिकल में तो नहीं आए हुए हैं, मैकेनिकल में ऐसे क्वेश्चन एक या दो बार आए हुए हैं. दैट अ करंट इज पासिंग थ्रू अ वायर एंड यू हैव टू कैलकुलेट बाय अप्लाइंग द बेसिक फॉर्मूला ऑफ P इज इक्वल टू VI और H इज इक्वल टू I स्क्वायर RT. दिस मच ऑफ नॉलेज इज एक्सपेक्टेड. आप ये नहीं बोल सकते कि सर ये तो इलेक्ट्रिकल का है. यू हैव ऑल्सो रेड द बेसिक इलेक्ट्रिकल इंजीनियरिंग एंड इट्स ऑल अबाउट द यूनिट्स ओनली. ओके, सो इलेक्ट्रिकल मेजरमेंट्स इंडिकेट दैट अ करंट ऑफ 10 एम्पियर passes, right, through the wire and there is a voltage drop of 8 volts. So this is I, right? Voltage drop delta V लिख सकते हो, V लिख सकते हो. It's voltage drop of 8 volts, correct? Along the wire, if the insulated wire is exposed to a medium, so what is the medium temperature? T infinity is equal to 30 degrees Celsius with a heat transfer coefficient of H is equal to 12 watt per meter square per degree Celsius. ठीक है? So that is the scenario given. क्या determine करना? We have to determine the temperature of the interface of the wire and the plastic cover, means wire and the plastic cover का जो interface है, we have to determine this temperature Ti at the steady state operation. Also that, okay, Ti, so fine. After this, they say that also determine whether doubling the thickness of the plastic cover will increase or decrease the interface temperature. We'll talk about that. But first of all, let us calculate this Ti. Now you will ask, sir, heat generation bhi nahi de. If you see this question and the previous question, what is the difference? First difference is heat generation data is not given. So that we have to find by using these two. Okay. The second difference is surface temperature is not given, and instead of that, they have provided us this T infinity temperature, the medium temperature. देखो इन सभी क्वेश्चंस में सेम कॉन्सेप्ट लगना है. At steady state, the Q in the insulation will be equal to the Q in the this medium. However, it will not be equal to Q everywhere in the generation part. So first of all, this is V and I. Do you know that what is the formula for P? P is equal to V into I, right? And these are all standard units. So P is equal to 8 into 10. That becomes 80, right? V into I. Okay. So V is 8 volts and I is 10 amperes. ये आपके जो स्टैंडर्ड यूनिट्स यूज होते हैं वही यूनिट्स हैं. सो ऑफ कोर्स जब ये मल्टीप्लाई होंगे तो जो आपको पावर की यूनिट मिलेगी वो स्टैंडर्ड यूनिट्स मिलेगी. एंड व्हाट इज द स्टैंडर्ड यूनिट ऑफ पावर? आई थिंक 80 watt, right? Power is the 80 watt. Now what is this? It is a kind of E generation. It is kind of E generation which is 80 watt. If you want me to express this in the form of Q generation, this is E generation. अगर इसको मैं Q generation, small q generation के फॉर्म में एक्सप्रेस करना चाहूँगा, so I'll have to divide this 80 watt by the volume of the wire. And what is the volume of the wire? Pi. अब R square लेना है, D square लेना है. Be very careful. Pi R square into L, right? So what is R square? 1.5 mm into 10 power minus 3 becomes meter. R square into 5. This is in meter cubes. Let's see what we are getting. So that becomes 0.0015, right? And a square multiplied by pi, right? And then multiplied by 5. Okay, 80 divided by this is giving you 80 divided by this. The answer is 2.263. 2.263536. Okay, so that becomes 1 2 3 4 5 6 into 10 power 6 watt per meter cube. I don't think इसकी जरूरत पड़ेगी, but still we wrote this. आप इसको 2.27 into 10 power 6 watt per meter cube भी लिख सकते हो. So from the data of current and voltage, I calculated that what is heat generated per unit volume and what is heat generated per unit time. Now the funda is we have to, the funda is that at steady state the heat conduction is equal. अब आप देखो, अब आपको यहाँ पे Tmax दिया है क्या? Even they are not asking you Tmax and they have not provided you Tmax. So why to go into that equation that Tmax minus Ti is equal to Qg R square by 4k, है ना? Because Tmax ना तो पूछा है ना तो बताया. In this case we are only involved here because they are asking me what they are asking. Ti they are asking, right? Yeah, they are asking Ti, right? So Ti, this is your surface temperatures. Let us call it Ts. Okay, let's see whether we can find the value without using the Tmax or not. Okay. Okay, so this is the 80 watt. 80 watt heat is being generated in the wire, and of course at steady state 80 watt will be leaving this. And if 80 watt is leaving, so even in convection this 80 watt will be leaving. So can I say that everywhere this 80 watt will be leaving? So यहाँ के बाद in the insulation, in the medium, 80 watt will be the rate of heat transfer. The units are fine, and therefore this is also what that must be equal to H, which is 12 multiplied by A. What is A? The surface area, which is 2 pi RL. What is the surface area? Yeah, it is 2 pi RL, right? Yeah, 2 pi RL. So or pi DL you can say. 2 pi RL लिख लेते हैं. 2 into pi into R, which will be 3.5 mm. So 3.5 into 10 power minus 3 into 5 meters. that is 2 pi RL multiplied by delta T. What is delta T? Ts minus 30. So from here you can determine Ts. Once you determine Ts, you know how to determine Ti, right? So that is Ts minus 30. So let's see, let's do this calculation. This is 12 into 2 into 3.5 into 5, right? And that multiplied by pi, right? Oh, I made a mistake, sorry. That becomes 12 into 2, 24. 24 into 3.5 and that multiplied by 5, right? That is multiplied by, answer multiplied by pi is this, and divided by 1, 2, 3. So okay, 1.319, right? So okay, T divided by this and plus 30. So the surface temperature is coming out to be 90.6. I hope the calculations are correct. 90.63. 90.63 degrees Celsius is the surface temperature. आपको surface temperature find करना था क्या? नहीं, we have to find the interface temperature. Now once you have the surface temperature, you can always use the formula of Q is equal to the driving force by the resistance, and in that case it will be and what is Q? Q is 80. 80 Q हमेशा रहेगा ना, इधर भी बाहर भी, यहाँ नहीं रहेगा. So 80 is equal to delta T, which is the Ti minus Ts. So Ti minus 90.63 divided by log of R2 by R1. What is R2? 3.5 and R1 is 1.5. Very good. 3.5 by 1.5 multiplied by 2 pi KL, right? That is 2 pi K की वैल्यू गड़बड़ यूज करी क्या हमने पहले? नहीं, अभी K की वैल्यू 0.15 यूज होगी, इससे पहले K की वैल्यू कहीं यूज नहीं हुई. So K of wire was not required here. K of wire is given? No, K of wire is not required because wire के अंदर की कैलकुलेशन करनी नहीं है. So 2 pi and K is 0.15 and length is 5. I hope no unit conversion is required. Okay, so 2 multiplied by pi multiplied by 0.15 multiplied by 5, right? So that, okay, so that 80 divided by this, मैं सभी को लेफ्ट हैंड साइड में ले रहा हूँ, और मल्टीप्लाइड बाय log of this 3 find log of 3.5 divided by 1.5. Okay, this plus 90.63 plus 90.63. The answer is 105. So Ti becomes 105. What was Ts? 90.63. So Ti is coming out to be 105.01 degrees Celsius. This is how you can do the calculation. Again, a very good problem on conduction plus this convection. देखो, इससे पहले वाले क्वेश्चन में I tried to relate the cylinder where heat generation was taking place and the insulation. In this problem, I tried to relate the insulation and the medium. Right? There can be a problem where T max is given, right, and medium temperature is given. Then they are asking the things. Be very careful. Don't apply that Q as this position at this position at this position will be same. Don't do this. Okay. These two problems will be a kind of eye opener for you. Now the question says also determine whether the doubling the thickness of the plastic cover will increase or decrease the interface temperature. इस thickness को बढ़ाने से आपका इंटरफेस का टेम्परेचर इंक्रीज होगा या डिक्रीज होगा. नाउ आई लीव दिस अपॉन यू. ऑफ कोर्स आई विल टेल यू द आंसर कि इसमें क्या होगा. इफ यू आर इंक्रीजिंग द थिकनेस, इंटरफेस के टेम्परेचर को क्या होगा, इसके बारे में सोचना. दिस इज अ वेरी गुड कॉन्सेप्ट दैट इंक्रीजिंग द थिकनेस हाउ इट इज गोइंग टू अफेक्ट द इंटरफेस टेम्परेचर. Okay, we'll talk about that. So that was a very good problem again based on conduction plus heat generation, and as well as we tried to include convection as well. Okay, so this was the third problem. Like this, I have selected a total 14 problems in conduction. है ना? I have not selected those where you have to just put the values. In heat transfer, there are many problems where you have to just put the values in the results of Fourier laws, right? तो थोड़ी बहुत हर जगह मैंने थोड़ी बहुत कुछ ना कुछ कॉम्प्लेक्सिटी डाली है ना. सो बेसिक फॉर्मूले फोरियर लॉ वाले मैंने नहीं करा. वैसे क्वेश्चन लेने का कोई मतलब नहीं है, वो चीजें आप अपने आप कर लोगे, राइट. फोर्थ प्रॉब्लम. ओके, so the fourth problem says, right, read out this problem. It says the temperature of a gas stream is to be measured by a thermocouple whose junction can be approximated as 1 millimeter diameter sphere. So diameter is equal to 1 millimeter. ठीक है, 1 millimeter dia. एंड ये स्फेयर है, ध्यान रहे. थर्मोकपल का जो बल्ब है दैट कैन बी अ स्फेरिकल बल्ब. ओके, whose junction, okay, fine, as a 1 millimeter diameter sphere, okay, the properties of the junction are K is equal to thermal conductivity is equal to 35 watt per meter per degree Celsius. Junction means the material K and material density is also given. Rho is equal to 8500 kg per meter cube and specific heat is equal to 320 joule per kg per degree Celsius. ठीक है? If the convection heat transfer coefficient between the junction and the gas H is equal to 210 watt per meter square per degree Celsius, determine how long will it take for the thermocouple to read 99% of the initial temperature difference. Okay, first of all, okay, I'll come to that. Let us see the units. मीटर, मीटर क्यूब, केजी, जूल, वॉट. इसमें भी ध्यान दिया करो, जूल एंड वॉट, क्योंकि कई बार लगता है कि जूल और किलो जूल होता है तो दिख जाता है, वॉट किलो वॉट होता है तो दिख जाता है. यू नो वॉट इज नथिंग बट जूल बाई सेकंड. बट इफ देयर इज जूल एंड किलो वॉट इन द प्रॉब्लम, यू हैव टू बी एक्स्ट्रा केयरफुल. ठीक है ना? तो यूनिट्स देख के चलो. यूनिट्स नहीं देखोगे, मैं पहले ही बता रहा हूँ, हीट ट्रांसफर में एटलीस्ट कंडक्शन में तो यार स्ट्रेट फॉरवर्ड प्रॉब्लम्स है. हाँ, अगर आपके कॉन्सेप्ट ढीले हैं तो पीछे वाले प्रॉब्लम्स आपको अच्छा खासा घुमा सकती है ना. समझ नहीं आएगा कि कहीं कुछ कर दे रहे हैं, कभी कुछ कर दे रहे हैं ना. इफ योर कॉन्सेप्ट्स आर नॉट प्रॉपर, इवन दोस टू सिंपल प्रॉब्लम्स विल बी डिफिकल्ट फॉर यू. So H is equal to 210 watt per meter square per degree Celsius. So I think no unit conversion is required except here in the diameter. So we'll take care of that. Determine how long will it take. Okay, first of all, let me write the formula. T minus T infinity is equal to Ti minus T infinity is equal to e raised to power minus Bt. I think B, you remember that it was Ha by rho Cp into V into T. ये फॉर्मूला तो भाई रटना है, ठीक है, ये ध्यान रहे. Now the question is, how long will it take for the thermocouple to read 99% of the initial temperature difference? When the thermocouple reads 99% of initial temperature difference, 99% of initial temperature difference, then 99% of initial temperature difference, then the remaining temperature difference, then the remaining temperature difference between the thermocouple and the medium, कितना भाई? 99% वो कवर कर चुका है. Thermocouple is already reading the 99% of initial temperature difference. So the remaining temperature difference will be 1%. What is remaining temperature difference? T minus T infinity at that particular time. Thermocouple reads 99% of initial temperature difference. मतलब, see, what was the initial temperature difference? Ti minus T infinity. अब thermocouple इस initial temperature difference के 99% को पार कर चुका है. And now the situation is T minus T infinity. So after already covering the 99% of initial temperature difference, then the remaining temperature difference between the thermocouple and the medium, will be 1%. ये समझ आया? सोचना इसके बारे में. will be 1%. 1% of initial temperature difference. ठीक है? The thermocouple is already reading 99% of the initial. It has, ये read क्या कर रहा है? मतलब अभी जो thermocouple read कर रहा है, that is 99%. It has already covered the 99% of journey and only 1% is remaining. What is the total journey? The total journey is the thermocouple shows the temperature equal to T infinity. Right now it has covered the 99% journey, so what is remaining is 1%. So T minus T infinity is 1% of Ti minus T infinity, and therefore this T minus T infinity by Ti minus T infinity can be written as 0.01 is equal to e raised to the power minus Ha divided by rho Cpv into T. Correct? ठीक है? तो अब they are asking how long will it take. You can find in seconds, और ये watt में है तो आपका आंसर सेकंड में आएगा. ठीक है? So let us calculate. This is 0.01. I can say that log of 0.01 will be this. ठीक है, तो log पता कर लेते हैं. Log of 0.01 is equal to minus Ha. What is H? Let us put the value directly. H is 210, है ना? Area is given to us or not? What is area? Volume by area can be taken as characteristic dimension. So, because nothing is given, what is characteristic dimension for a sphere? R by 3. So, volume by area is characteristic dimension, that will become R by 3. So, 3 goes into the numerator. So, 3, right, into T, correct, by rho. So, what is rho? 8500. Everything is standard. What is Cp? There is also kg. So, 320. And here it should be R, right? So, what is R? This is 1 millimeter diameter. Be careful. R is 1 millimeter diameter. So, it should be R. Diameter is 1 millimeter. So, R is 0.5 millimeter. So, it should be 0.5 into 10 to the power minus 3. Everything is in standard units. What is log of 0.01? Negative value 0.01. That is minus 4.605. Negative negative gets cancelled. Minus 4.6 is equal to, right, 210 into 3, that is 630. 630 with a negative sign into T divided by 8500 into 320 into 0.5, correct, divided by, that becomes 1360. Okay, so 1360, that multiplied by 4.6 and divided by 630. T is 99.3 seconds. Right, because the answer, the question was given in watts, so the answer will be in seconds. This was the problem on Biot number, unsteady state heat conduction. आप बोलोगे सर आपने चेक नहीं किया, right? In gate problems, you need not to check. Most of the time, it will be mentioned that it can be assumed as a lumped heat capacity, right? But let us also verify that H into what was the Biot number? H into the characteristic dimension divided by K, right? So H was H is 210. 210, right, and what is K? 35. H into characteristic dimension. The characteristic dimension is R by 3, right? So H into 0.5 into R by 3, right? So that becomes okay, that is R. So H into L, okay, right, divided by 3,100 and that divided by 35. It is coming out to be 1 into 10 raised to the power minus 3. So it is well in the limits of lumped heat capacity, and that is why I knew that this is going to happen. If you want to check, you want to verify whether your question falls under the limit of lumped heat capacity analysis or not, definitely you can always calculate the value of Biot number.